Hey there, this is Math 6, Unit 4, Lesson 14, Fractional Lengths in Triangles and Prisms. Let's explore area and volume when fractions are involved. So first of all, we have find the area of a triangle. When we find the area of a triangle in square centimeters, we're going to show you reasoning here. The area of a triangle, let's remember that the area of a triangle is equal to 1/2 of the base times the height. And we showed that to be true a long time ago by saying that if we know the area of a square is the base times the height, a triangle is going to be half of that, right? So that's how we end up with that formula. We have our area of the square, or a rectangle, and we're cutting that into half. So in this case here, I know that I have an area is A. I have a base and a height. Now the reason we're going to call this the base and the height is because of where this 90-degree angle is at. That's the key thing to keep in mind from your prior learning. Where's 90 degree at? So where this line comes from a vertex down to a 90 degree, right? Then that's going to be our height there. These are the same numbers, so it doesn't make a big difference, but just want to make sure we have the same idea. So 1/2 times 4.5 times 4.5 will give me the area. So this is a half times 2 times 4 is 8, plus 1 is 9, so 9/2 times another 9/2. We can't reduce this way, nothing reduces, so we're just left with 81 over 2 times 2 is 4, 4 times 2 is 8. We have 81 over 8, which is the same as 10 and 1/8 there. Okay? So that's using our formula there. We know we have our height. Here's our height right here, and here's our base right there. And we're set for the area of a triangle. Now let's use that information now to move on to the next activity. The area of triangle B is 8 square units. Find the length of B. So what are we doing now? Well, it's like we did on our last activity. We're saying we're not going to give you all the information. We're going to have you work the other way. Instead of finding the area, we're going to find the missing length here. Okay? So what do we know? We know the whole area is 8. That's great. We know that. We have a height. Why is it a height? Because it comes down and makes 90 degrees. We have a height there, and we don't know that part there. So think of it this way. We know that area equals 1/2 times the base times the height, and we're given the area is 8. We keep the half like it is. We don't know the base this time, so we can say base there. And we know the height is 8 over 3. Now before, we were making this into a division problem by just dividing 8 divided by whatever is over here. But now we have two things. So it's okay to combine these first of all. Alright? So what is 1 times 8? 1 times 8 is 8. And 2 times 3 is 6. I'm going to leave it just like that for now. Okay? I don't have a problem with leaving it like that. Some people might want to reduce it. If you chose to reduce it, you certainly can. Doesn't make a difference, okay? I'm going to reduce mine later on when I need to. Right now, I'm going to leave it just so I can make sure I see how this works. So I have 8 equals 8/6 times b. So to make that in a division problem, this becomes 8 divided by 8/6 equals b. Okay? So we're just, to move this over to there, I have to divide. So I have 8 divided by 8/6 equals b. I'm going to write this right up here again just so we can see a little nicer. So this is 8 divided by 8/6 equals b. We're going to multiply by the reciprocal. And when I do that, notice what happens to the 8's. They all cancel out. And we are left with 6 equals b. Now if you reduce, you have another step there. That's okay. I chose not to reduce, so I end up with just 6. Works out just fine. So the base in this case would be 6. So we can find an unknown length even with a triangle formula, even though there are lots more variables. Instead of just saying like 2 of them, we have 3. But I just combined my half and my fraction first before I moved things around. That made it a lot easier for me. That was my choice for how to do that. Are there other ways? Yes. That's what I did. Okay, the area of this one is 54/5. We have a length here. What is the length of the h, the height right there? Again, it's a height because off of a vertex down to a 90-degree angle. So there we go. So we know we can take a 3 3/5 times a half times the height, right? So this is my length times a half times the height is all equal to the area, which is 54 over 5. Okay, now I wrote that really funny order, didn't I? I just started writing. I'm so sorry about that. So this really, if I wrote it the way I did before, I would have done area equals 1/2 times base times height. And then I would have stuck in 54 over 5 equals a half times 3 3/5 times the height. This is the same as that. I just did it backwards. Okay, don't worry about that, okay? So I'll come back over here. So 5 times 3 is 15, plus 3 more is 18. So we have 18 over 5 times a half times the height that I don't know equals 54 over 5. So I'm going to go ahead and do this real quick. I know that 2 reduces the 18 to 9. So I end up with 9/5. 9/5 times h equals 54 over 5. To get the h by itself, I'm going to divide this by 9/5. So h equals 54/5 divided by 9/5. And then for this, we multiply by the reciprocal, 5 over 9. And I had the 5's reduced to 1 and 1. And 9 times 6 is 54. So we know the answer is going to be 6. So I have a height of 6 again. It might seem strange to have the answer 6 2 times in a row, but that is the correct answer. It's just what it is. All right, so there we go. That is what we get for number 2. All right, number 3. Volumes of cubes and prisms. All right. Your teacher will give you a set of cubes with an edge length of 1/2 of an inch. Use them to help you answer the question. Okay, so it says we're going to give you some blocks, right? So here's a drawing of a cube with an edge length of 1 inch. How many cubes with edge lengths of a half inch are needed to fill the cube? So let's think back to before when we were doing the area and we had an area like this and like this. I'm going to pause there. So we had the 1 inch square and we divided into sections to say if this was a half and a half and a half, we knew we could get 4 inside that space there. Okay? So now we're doing the same thing, but we're going 3-dimensional. We're looking at a cube instead of just a square. So we're talking about volume instead of area here. That's the idea. So the question is, how many cubes with a 1/2 inch would it take to fill the cube there? So again, thinking that you are going to have a bottom down here like so, we're having 4 of these here. I'm going to have 4 on the base there, but I'm also going to have another layer of them because I have a layer here and here. So if we take a look at the little applet that we had, the idea is being that we know we're going to go at least 2 blocks long. Oops, that's 3. We're going to go 2 blocks long that way, and we're going to go 2 blocks wide. So we had that base of a 4x4, right? If we're assuming each of these are half, half to make 1, half to make 1. Now, in order for me to go out to the next one, right? To go next, I want to go high. I'm going to go up 2 as well, and we'll have a shape that looks something like that. When I do that, what do I end up with? As I end up with 1, 2, 3, 4, 5, 6, 7, 8 cubes all together to make that shape there. That's what I'm going to have, because I'm going to have a layer of 4 and another layer of 4 on top of that to get to where I need to be. Okay? So that's the idea with that one. So what is the volume in cubic inches of a cube with an edge length of a 1/2 of an inch? So we're thinking about volume being, okay, well, how many of the cubes, how many of these little 1/2 inch cubes fit inside of that space? Okay, in that space, we knew that there were 8 cubes altogether. So the volume of one of those guys is going to be 1 out of the 8 needed to fill the whole thing. If we think about it in terms of volume, volume is going to be a length times a width times a height. So in our case, it's a half times a half times a half, which equals 1 over 2 times 2 is 4. 4 times 2 is 8, so 1/8 there. So we just want to be able to show visually why that makes sense. Why is a 1/2 inch cube only going to have a volume of 1/8? That's because when you put it back into the 1 inch by the 1 inch cubed cube, it only takes up 1/8 of the space. It says 4 cubes are piled in a single stack to make a prism. Each cube has an edge length of a half. Sketch the prism and find its volume. Okay, so we're going to say, well, we're going to have a cube that has a 1/2 of an inch, and it says we have 4 of these 1/2 inchers. So there's 1, 2, 3, and 4. Now to make it into a prism, I'm going to go like this, and like this, and we'll draw lines there. Right, so these are all a 1/2 and a 1/2 and a 1/2. We want to find the volume of this whole thing. Now the volume in this case is going to be, I have a 1/2 and a 1/2 and a 1/2 and a 1/2. I know my base is still a 1/2. I know my width might still be a 1/2, but my height is no longer 1/2, is it? I have a 1/2 plus a 1/2 plus a 1/2 plus a 1/2, or 1, 2, 3, 4 halves over 2, which is the same as what? What is 4 divided by 2? It's going to be equal to 2. Or I can think of it this way. That's 1, 1/2 and a 1/2, and that's 1, 1/2 and a 1/2. So I know I'm sitting there at 2, so multiply it by 2, or 2 over 1. And when I do that, these cancel out, and I'm left with just the 1/2. So the volume of this shape is 1/2 of an inch cubed, right there. 1/2 of an inch cubed. Which, think about this, does that make sense? Why would that make sense? How many cubes do we have? We have 4. How many are needed to make the entire actual 1 inch by 1 inch cubed? How many do I need? I need 8. Well, I have 4 out of the 8. How much is that? 4 out of 8 is a 1/2. So it makes sense. I'm just rearranging the way those things are stacked up. It still shows me that I only have 1/2 of what I need to make an entire 1 inch cube. Alright. Use cubes with a 1/2 inch length to build prisms with lengths and widths and heights shown in the table below. For each prism, record in the table how many 1/2 inch cubes can be packed into the prism and the volume of the prism. Okay, so we have prism length of a 1/2 and a 1/2 and a height of a 1/2. Number of 1/2 inch cubes in the prism. Okay, so this is like going back to our little thing here. We're doing, if we're going to go each of these is a 1/2, then we're going to say I have a 1/2 and a 1/2 and a 1/2. I just have one of these guys is all that I have. So the number of cubes I'm going to have is simply going to be 1. And the volume is going to be 2, 4, and then 8. We have 1/8 there. The next one says if I have the length being 1, okay, and the width is 1, and the prism height is a 1/2 of prism height, okay, so that's going to be the number of how many cubes do I need there? Well, all right. So let's do this. To go a length of 1, that means I need 2 of these guys. Whoops, too far. And a width of 1 means I need 2 of those guys. There we are. So there's my 1 and my 1. I need 2 of them because they're each a 1/2. So that's every time it's, why am I doing 2? Because it's a 1/2 multiplied by 2. So right now I have 1, 2, 3, 4 so far. And the height is already there, so I don't have to do anything. So height is 4. And what's my volume going to be? Well, it's out of 8. So how many do I have out of 8 there? In this case here, we would say I have 1/2 of them, right? Yep. Okay, my notes just look a little funny there. Okay, so I have 1 times 1 times a 1/2, so I end up with a 1/2. Okay, the next one, the length is going to be 2. So again, I got to double that since I'm using 1/2 inch things. So I'm going to make the length 4. Okay. My prism is 1, my width is 1, so there's my 4 and my 1. And the height is still that. So how many cubes did I use? I used 1, 2, 3, 4, 5, 6, 7, 8 cubes. And my volume is going to be equal to 1. Why is it equal to 1? Well, 2 times 1 is 2, and 2 times a 1/2 is 1. All right, the next one, now we're going to go, we had that's already 2. We're going to go prism, the width, we're going to increase it to 2, which means I got to go to 4. So there's 4. So I'm at 4 by 4 because, again, 2 of them equal an inch. Inch, okay? So I'm at 2 by 2, which is going to be there. And my height has to go to 1 inch now too. So I got to go the height up one more. So far I have a 4 by 4. That's 16 so far. Just make a little note there. And now I'm going to add another layer. So I have 16 plus 16, which is going to be 32. Now, what is that volume going to be? All right, the volume is going to be length times width times height. 2 times 2 is 4, times 1 is still 4. And you can see inside of here, I actually have 4 cubes side by side right there. 4 1-inch cubes side by side. All right, in our next one, we're going to do our length to 4, which again, times 2, so I got to go up to 8. There's 8. That stays the same. And our height, though, is going to go up to 3 over 2, which means I need to go up one more on my height. Okay, let's go up one more on my height. There we go. Looks like that. Wow, that's joyous. How many blocks is that going to be? Well, I have a 4 by 8, which is 32 layer here. And I'm going to do it 3 times. So I have 32 times 3. Which is going to be 96 blocks. Wow, that's a lot of blocks. I don't know if you're using real blocks or the little applet here, but I don't have 96 blocks to play with. For our volume, we're going to do 4 times 2, which is 8, and then 8 times 3 over 2 reduces to 4 and 1, which becomes simply 4 times 3 is 12. And then we're going to go 5 inches, oh my goodness, out to 10. So we're there. That saves 4. This is going to go up one more to block the height. It's going to go to 4. So now we're here. We have 5. Oh, we got to go 4. Oh, I got to increase that. This will be 10 blocks long, 8 blocks wide, and 4 blocks tall. One more. Okay, cool. We have that massive thing there. This is a lot of blocks. So, how many blocks do I have? Well, I end up with 10 by 8 on the top. 10 here, 8 there, that's 80. And 80 times 4 is 320. So, right, this is 80 times 4. 320. And in terms of the volume, I don't want to count all those. This is going to get crazy when I count all these, right? So I just want to do 5 times 4 is 20. 20 times 2 is 40. That's a whole lot easier than counting all of that. This is why we do these things, right? Okay, and our last one here, this stays, so I know I still have a 10 by 8, so I'm still sitting at 80, but now I'm going to go up another half a level. So now I have 5 of those rows, right? 5 of those rows. So I have 80 times 5, this is 5 of them. 80 times 5 is going to be 400. That's how many blocks I'm using. I have a 10 by 8, which is 80 times 5 or 400. Now for the area, 5 times 4 is 20. 20 times 2.5 is 50. Okay. So when we analyze the table, what do we notice about the relationship between the edge lengths of the prism and its volume? What we notice here is we notice that the volume is going to be related to the length times the width times the height. Again and again. That's the way that's going to work out. So what's the volume of a rectangular prism that is 1.5 inches by 2 1/4 by 4? Well, we multiply those things together. We're going to do 1.5 times 2 1/4 times 4. I can make these mixed numbers into improper fractions. 2 times 1 is 2, plus 1 is 3, so 3 over 2. Times 4 times 2 is 8, plus 1 is 9. And then times 4 over 1. So now we can reduce here. That becomes 1 and 1. I can't reduce with 9s and 2s and 3s, so it stays what it is. So 9 times 3 is 27 over 2. And 27 divided by 2 is going to be 13 with 1 left over. So 13.5 inches cubed becomes the volume for something like that. Alrighty. Okay, and we're going to go straight to the summary now. I know there's an Are You Ready for More, but we're going to go straight to the summary. And it says, if a regular prism has edge lengths of 2 units and 3 units and 5 units, we can think of it as 2 layers of unit cubes, with each layer having 3 by 5 unit cubes, right? So here's a 3 by 5, and we have layer 1 and layer 2. So the volume is the number of layers times the length times the width, and that's what we get for the volume there. To find the volume of a rectangular prism with fractional edge lengths, we can think of it as being built of cubes that have a unit fraction for the edge length. For instance, if we build a prism that's a ½ an inch tall and 3½ inches wide and 4 inches long using ½ inch cubes like we did before, it's going to be a little different. Okay, a height of 1 cube, a width of 3 cubes, and a length of 8 cubes. It's just going to be a little bit different there. Okay, so anyways, that's how you get your half, your 3/2, and 4. So we were kind of playing with that before, right? So if we knew that if that's the 1, to make it into halves, we cut it up, and so it takes 2 of these to make 1. Right? Just something to keep in mind if we use fractions. So that's how the fractions work, even with volume as well. We could divide it into 1/4 inch cubes, right? We could do it with fourths like this, and then you have a lot more in there. Those are 1/4 inch. They're more, but that'd be a lot of blocks to utilize. Okay? So we're going to pause there, work on our homework, and come back together to check it in just a moment. All right, homework for lesson 14. It says Claire is using little wooden cubes with edge length ½ inch to build a larger cube that has edge lengths of 4 inches. How many little cubes does she need? Explain your reasoning. Okay, so how many would she need? Let's think of it this way. To make, if I have a ½ inch cube, I'm going to need 2 of those, right? These are halves, to make 1 inch. Okay? She wants to go into, right? She wants to go to make a cube that has 4 as the 4 inches of length there. So that's 1. So to make a 4 inch thing, she need, that's 2. Here's 3, and here's 4, right? So if she's going to go 4 inches long, she's going to need 1, 2, 3, 4, 5, 6, 7, 8 cubes to go 4 inches in length. But we're doing 4 inches in length and 4 inches in height and 4 inches in width. So if I want to know how many cubes she needs altogether for the whole thing, it's not just going to be 8, it's going to be 8 times 8 times 8, which is 512 cubes is how many she would need to make a 4 inch cubed cube. Okay? All right. Number 2. The triangle has an area of 7 7/8 and a base of 5 1/4. What's the length there? Or what's the height? Okay, so what we're going to do is we think about this as before, so kind of review one. Area equals 1/2 times the base times the height. And then we go where the area is given to us as 7 7/8 equals 1/2 times, and then we'll go with 5 1/4 times the height that I don't know. Let's rewrite this as 7 7/8 equals 1/2 times 5 times 4 is 20 plus 1 is 21 over 4. So that becomes 21/8. Okay, this one, 21 over 8 times h. This is 56 plus 7 is 63. So I'm right here, I'm looking at this by just plugging the numbers in and making them into improper fractions. But now let's turn this into a division problem. So this becomes 63 over 8 divided by that number right there, 21 over 8. We multiply by the reciprocal. So 8 over 21, reduce to 1 and 1. 7 goes in here 3 times, 7 goes in here 9 times. So I end up with 9 over 3, which reduces down to 3. So my height is going to be 3 centimeters. So a long way to get there, a lot of math problems, a lot of places where you might make a little simple computational error, but you end up with just 3 as the answer. Okay, number 3, which of the following expressions can be used to find how many cubes with an edge length of 1/3 unit fit in a prism that's 5 units by 5 units by 8 units. Okay, so think about this. If the unit is 5, like this, 1, 2, 3, 4. Okay, if the unit is 5 units long, we got to make them into lengths of thirds, which means I'm chopping everything up into thirds, right? Like this, which is a lot, which means I'm multiplying 5 times 1/3 is going to tell me how many I'm going to end up, not times 5 times, 3 is going to tell me how many I'm going to end up with, where in this case is 15. Sorry, I looked over here and saw the third. So because I have 3 here, I'm going to do this 5 times, which means that in this one I need 15. That's what I'm going to have. I'm going to have 15 in my one unit, another unit, and my final unit will also need 8 times that, which is going to be that many. So when I look over here, this is making them less. I don't want that. That's not going to work. This is what I already have. That's not going to work because I have to break it up into pieces of 3. And this is what I'm doing right there, which works out great. Excuse me. All right, so we're going to go with choice 3. May says we can also find the answer by multiplying the edge lengths of the prism and then multiplying the result by 27. Do you agree with her statement? Well, so she's saying take the edge lengths and do 5 times 5 times 8 and then multiply by 27. How does that compare with what we see right here? Here I have 5 times 5 times 8, so that's all good to go. And then the 27. Well, I'm left with a 3 and a 3 and a 3. Well, 3 times 3 is 9, and then times one more 3 is 27. So, is that going to be okay? Sure, it's going to work out just fine. She can certainly do that because the 27 represents the 3 times 3 times 3. Okay, a builder is building a wood fence with 6 1/4 inch wide wooden boards arranged side by side with no gaps. 6 1/4 inch. 6 1/4 inch. How many boards are needed to build a fence that is 150 inches long? So we have a fence that's 150 inches long, and we're going to put inside of it 6 1/4 inch boards. So how many does it take to fill that length? Right? So it's like, as multiplication, it's 6 1/4 times what will give me 150. As division, it's 150 divided by 6 1/4. So 4 times 6 is 24, plus 1 is 25. So we have 150 divided by 25 over 4. We're going to multiply by the reciprocal. So 4 over 25. 25 goes into 150 6 times, and 6 times 4 is 24. Sorry. Number 5. Find the value of each expression, show your reasoning, and check your answer. So we're going to go with 7 times 2 is 14 plus 1 is 15. So 15 over 7. And we're going to multiply it by the reciprocal, which is 7 over 2. Reduce, reduce. And we have 15 over 2, which is equal to 7 1/2. Here, we're going to leave 17 over 20 as it is and multiply by the reciprocal. So reduce here 1 and 5. And we have 17 over 5. 5 goes in here 3 times with 2 left over. So the bucket contains a bucket contains 11 2/3 gallons of water, and it's 5/6 full. How many gallons of water would be in a full bucket? Okay, so we know we have 11 2/3 in it, and it's 5/6 of the whole thing. Okay, so what we know basically so far is that it's 5/6 of full is 11 2/3. That's what I have. I have 11 2/3 gallons of water, and it's 5/6 of being full. So this is like writing a multiplication problem. Is 5/6 times something I don't know, the full amount, is equal to 11 2/3. So this is a division problem. This becomes 11 2/3 divided by 5/6. So 33 plus 2 is 35. Oops, 35 over 3. Times the reciprocal, 6 over 5. 5 goes into 35 7 times. 3 goes into 6 2 times. So I'm left with simply 14. So the whole bucket can actually hold 14 gallons in all. Number 7. There are 80 kids in a gym. 75% are wearing socks. How many are not wearing socks? If you get stuck, draw a tape diagram. Well, let's do it. So here we go. So we have a tape diagram, and there's our whole thing. And we're going to make sections of 25% because we know that 75 works there nicely, right? So this is 75%. Right there is 75%. We know that there are 80 kids total. In the whole thing, there are 80 kids total. Right? You okay with that? So, how much is in each section? Well, there are 4 parts there. So I can think of this being 80 divided by 4, which is going to be equal to 20. So in every section there are 20, 20, 20, 20. So how many kids are not wearing socks is what's located right here, which is going to be simply 20 kids are not wearing socks. It tells me also 2, 4, 6, 60 kids are wearing socks. All right, and number 8. Lynn wants to save $75 for a trip to the city. If she's saved $37.50 so far, what percentage of her goal has she saved? And what percentage remains? So we want to know, in a sense, what percentage that's going to be. She's saved $37.50 out of the $75 she wants to save. So when we do $37.50 divided by 75, you end up with 0.50. So to turn that into a percentage, we multiply by 100, or move the decimal over 2 spots, and that's going to be 50%. So in our case, she saved 50%, and it's a nice number. What percent remains is the other 50%. Now Noah wants to go to a concert, he wants to save $60 so he can purchase a concert ticket. He's saved $45 so far, so what percentage of his goal has he saved? So he has saved $45 out of the needed $60. Okay, so we could think about this as a, again, division problem. Okay, that's easy enough. We can get this in terms of hundreds. How are you going to do that? So 45 divided by 60 is equal to 0.75. To turn that into a percentage, we multiply by 100, which means move the decimal over 2 spots, which is 75%. So far he has saved 75%, and what remains is 100 minus 75, which is 25%. That's what's left over there. As a tape diagram, in case you're wondering here, we could do something like this. He needs $60, so half of it's 30, right? So that's 30, which means that each one of these is 15, 15. Well, 15 plus 15 plus 15 is, again, $45, which just shows me 25%, 50%, and 75% there. So what's left is 25%, or another $15. All right, I think that's it for the day. Sorry that I was choking on you all today. It's kind of early and just how it is. Have a great day. See you next time.